record. All right. I would like to welcome everyone here for the Seattle Crafter Meetup. We are a monthly meetup where we get together and we talk about code craft and the art of writing code as humans. In the past, that's been a lot of different ways. We were meeting in person for many years. Then we switched to online during COVID, and we've kept online since then. We generally get some very interesting people. Not generally, we always try to get as interesting people as we possibly can to talk and keep it topical and relevant. This year, we've been doing a lot of talks about AI, and that's very specific because number one, we cannot be writing code right now without hearing and interacting with AI. And we think that it is important. It is not the only thing to be thinking about, however. We still believe in codecraft and the art of writing code. And we strongly believe that crafters that take pride and knowledge in the art of writing code make better developers and are really enhanced with AI, as opposed to those coming out of school and just using AI and starting to feel their skill atrophy a little bit. We've been around doing it a while and seems pretty straightforward. But with that, we search the world high and low. We have friends of the channel. Some of them are in attendance today. And we have some regular speakers, and we have some speakers that come in and out, and we have new speakers. We definitely open this up to new opportunities for people that want to break into trying to speak. We're a friendly community for that. We firmly believe that we should grow the community and give back as well too. So if you're interested in speaking at the Seattle Crafter Meetup, ping either me or Paige. You can do it here in Slack at the Seattle Crafter Meetup Slack channel, or through Meetup, you can reach out to us. We're happy to respond and talk about that. And with that, we have a woman who's here to talk to us today. I met Lada. Lada was introduced to me by Llewellyn Falco one year saying, hey, I'd like to do this talk with this amazing developer that I've been working with. And she doesn't have a whole bunch of public speaking experience with meetups, but we'd like to do it together. So we did that. And that was the first time I remember meeting Lada. Since then, I've met her at Agile Open Northwest, and I've met her at, I think it was the big Agile conference. I think you were there too. Yes, you were. Actually, I invited you there. What am I talking about? Yeah. And I love to code with Lada. Her laugh and her energy, just like you heard, is there. She calls me out when I need to be called out, and I appreciate it. And she's fun. She's got great, fabulous ideas. And I'm lucky that we got her. She was at Craft less than a month ago. She's traveling the world, super busy. And so this is a delight to have her here. Lada, I'd like to open up the floor to you and say, here you go. Enjoy Patterns for Coding with AI with Lada.
Thanks so much, Steve. Hello everyone. This is a talk about coding with agentic AI. I've done it about September last year, but it's been due to a refresh. So let's go into it. So, right. So I will start with I'll start with my impression of what it felt like in the last 2 years or so to be coding with agentic AI. Right. So basically, the process looks something like this. So the genie. Ken Beck talks about it. He calls it the genie, and this is not the genie from the book, the movies, right? So the genie from Aladdin movie is like there to please you. This one is a tricky one from the books, right? And the genie from the books is there to get you. So you go, like Ken Beck says, basically it grants you wishes, but it's not what you asked for. So the process looks like this. You go to a genie and you're like, hey, can you write me some software, right? And the genie then goes and pulls the laptop, goes to work, and out comes working software. Well, I guess hopefully it works. I mean, it often does, maybe. And then you kind of expect it to look at all that stuff and be like, I guess it looks good to me. So that's what it felt like an engineer with 15 years of experience to me. It keeps feeling that way to be coding with AI, right? And so how you feel about this depends, right? So if you're an engineer like me, you probably are like, what is this madness? How do we even work with this? But like people who are like product managers, that's been their life most of the time, right? They go to a developer, they're like, hey, I'd like some software. And sometimes it works. And you go from there. So less weird. But to us, it is weird, right? So I've been kind of spending a lot of time in the last year, in the last year and a half, and so figuring out how do you even like how do you control this thing? Like what can you even do, right? And thing is, like I actually started exploring it a lot, uh, pretty much when it became agentic, right? So luckily, because before I was like, oh, this is not very good, and I think it wasn't. But then one day I was like stuck on a project as a backend developer, and I didn't have a front end, right? And there was nobody to help me with the front end. And I wanted to show my work because my work on the backend was done. So basically, like I was like, this agentic thing is a thing. Maybe I'll try it. And I tried, and I pretty much iteratively in a evening made myself an Angular front end. And the next day, I'm showing my work and getting compliments for my design skills that don't exist. Right? So this is what made me start to pay attention and start to explore this thing. Because when something makes you more powerful and makes you skills, gives you, lets you borrow a skill that you didn't have, I think that's a signal that you need to pay attention. There's something there. So, but to control something, I like to think about how do like what do you even can control? So like what can we even control here? What leverage do we have? So first of all, we're a developer, right? We're here. For the most part, let's pretend that we control ourselves. And then there's a foundational model somewhere, right? This can be a model in the cloud. This can be like on your local machine. It's somewhere you need to talk to it. So previously, we used to talk to it in a browser, right? Nowadays, like there's this agentic tool that is like Claude Code or like whatever your tool of choice is, that allows us to communicate with it. And what can you do with this picture, right? So first of all, you can choose the agentic coding tool you have, right? And that allows like that sometimes comes with a specific model, so you can kind of choose the foundational model that comes with it. Um, um, and then you can configure this. So you can think about like AI by default comes with a configuration that's not very helpful. It's not necessarily like it's not you open the browser window and click on something and say check mark, right? It's something else, but it's still this kind of thing, right? Configure. Um, and then you can give it tools to make it more powerful, or tune it to what you want, or restrict it to not let it go wild in your code bases. And then you can navigate on this point, right? You can do something different as a developer. You can tell it what to do and not to do, or you can automate a lot of things, which I highly recommend, right? So this is how you know. So this is what we can control. So like I said, been exploring extensively this year, and this is what we're gonna go through today. Some people reported fear when they saw this picture. I understand, but what I want to say, like, so first of all, I got you. Nobody reported fear at the end so far. But like really, it's imagine this is a three tracks, right? So like imagine we got to a new territory and I've been here a week longer maybe with some, or maybe I just explored different trails than you did. And I'm just gonna guide you through three different hikes and show you my trails, like what I found that has been helpful to me. Because I find that with AI, it makes a lot of difference how you work with it. And like usually people like it's really hard to teach as well, right? So how do you teach this stuff, right? What do you do? Oh, come here. Let's do something and like for 5 minutes stare at a screen, stare at it's working. That's just kind of dumb, right? So how do you teach this? So I distilled it to patterns, and I like patterns because they allow us to communicate. It's also by chunk pieces, and they're kind of my pieces, not trying to be any authority here, right? But you can also come up with your own, and I hope you do, right? And they can also be combined. So I'll show a little bit of those accords of patterns at the end, towards the end of the talk. Right. So there are also going to be a couple of pit stops in between. So I tend to kind of do a trail and then stop for questions a little bit. because it's pretty dense, right? And some people have seen this already, but there's been some updates and some new stuff, and some patterns that should have been there but haven't been in the first version. So very happy to, if you want to interrupt me in the middle, you're welcome to do that as well. Please ask questions, but like if you want to hold on to the pit stop, you're totally fine as well. All right, so 29 patterns, I got resources, right? Let me stop for this for a second. So first of all, there's a page with resources. There's a company website where you can follow the whole map. And the slides, and in general, like I will stop on this slide later at the end as well if you're gonna be interested in the end. All right, so let's just dive into this. All right, so I like to think about so AI is a thing that nobody really understands, right? But I really like to think about it from the space of like, what are the problems, right? I find it's very helpful to see the limitations that we're dealing with, so we can actually come up with ideas how to deal with that or figure out some ways to deal with that. So, and the biggest problem that I see so far with AI is that it can't learn from you, right? And people might be like, oh, wait, what? Like the whole point is like it learns, right? The whole point it steals the knowledge. Um, so what do you mean by can't learn? Well, first of all, we have fixed model weights, right? So basically it learned up to this point, and at some point it's like, no more books for you, go work, right? Um, So you can't change its mind by talking to it. You like if I get an intern, they usually pretty smart, and they the next day they won't repeat the same mistake. With this thing, it's total like new day every day. So, like first day every day, and then it's stateless, and stateless is interesting, right? So what does it mean stateless, right? So first of all, memory that you get with it is a lie, right? It's actually a pretend thing. And it's really helpful to understand the fine because, so like, first of all, what do I mean by that, right? So when you talk to LM via an API, so without any tool built on top of that, the experience is basically goes like this. Like you go to an AI and say, hey, can you pick a random number for me? And it's like, okay, well, 7. Okay, and you're like, okay, is this even? And thing is, the next thing it says, if you talk through API, is like, what's even? Because it forgot everything. It only sees your last message. Your prompt is this thing over here. That's your prompt, right? And I guess you can agree with me that this is probably not a very good user experience, right? So nobody does that, naturally. So what everybody does, including the browser, is pretend that there's a memory. And how do they do that? Well, they just extend the whole message with the whole history of your conversation. So basically, they have a bag, which is like they call it context window, right? Or a giant string, if you will. And the experience with that context window, at the start of the conversation, every time it gets a new one when you start, and at the start of the conversation is fresh, right? Nothing's there. And then you start talking to it. And when you start talking to it, like you put your first message in there, it goes into that context, right? And then the genie looks at it and like replies. But then when you say something else, then this is what gets sent, right? So all the previous history of the conversations, plus the tool calls that are not visible. So when you look at something, this is not your context. This is an image of your context, right? Something else might be in there, like your skills, like a system prompt, all of that stuff. And then the genie looks at that, and now it sees the whole history. Now it makes sense, right? This is your new prompt that makes sense to it, and it says, no, it's odd, right? So basically, this is what it looks like at the end of this interaction, right? With whatever secrecy things they're not showing us here. And that's how a new context window, and that's the current state. So basically, your tool sneakily sneaks in the whole conversation underneath without you knowing it. And if you think that, oh, does it mean that like the big conversations are basically need to be tokenized and like cost more? Absolutely. I think they're doing some caching, but that is the case. All right. So there's a pretend memory, right? And we have a fixed weights thing, and this pretend memory is a thing, right? Context. And the context is not something you tend to have control over, at least the tools don't allow you to sneak into it. I kind of really want scissors to cut stuff out of there, but yeah, it's hard. And the only operations with this context is you can start a new conversation, or you can refresh, or you can So okay, you can append, right? So you can send a message, right? Right. That's interacting with context, and you can restart. You can start from fresh, right? So given that this is the two operations you have, how do you manage context? So um, that's one of the biggest problems, right? But then another problem is that that string that we're talking about is actually not universal. So the context basically degrades as conversation progresses, and LLMs stops following more and more instructions. That's how it manifests. And that happens long, long before the context window limit is reached, which is interesting because the like Anthropic and folks are starting to be like, oh, here's a 1 million context window. And it's actually pretty helpful, but also not because really you're not getting the same value for the same mileage, right? So um, basically, I'm thinking about it. Just imaginary, knowing scale that the context is basically like really good at start, green, and then it gets worse, and then it really is bad. So like your first interactions with it will go really well, and then it goes on degrades, and then and goes on just plummets to death, right? And the experience you're gonna get with this thing depends on when you're asking the questions. What's in there? How long it's been, right? You won't have the same quality when you ask later. It depends. It's not as trivial, but like oftentimes it's very very noticeable, right? So that leads us to a first pattern and of a broadest pattern, like we have to manage context. We can't just be thoughtless about what we put in there, right? So okay, so AI can't learn, right? And the context drops. So we have something that actually degrades as your conversation progresses. So we have to manage context. All right, how do you manage context? The simplest pattern that exists right now, but surprisingly, not everybody is doing that yet. But people who are doing that reporting a lot more success, and teams who are doing it is actually has been measured. So what can you do? Well, you're dealing with something ephemeral here, right? So when a conversation opens, you have a window, and you putting in things in there, and say this is like no way a perfect image, but imagine this is your context at the end of life, right? So it's been kind of garbage with a lot of stuff. There's a lot of things there, but there's also they're not equivalent things, right? Some things are like tool goals that you don't care about long term, but some things are really valuable because you just explain your whole project or your goal, your long-term goal you're trying to do, or like you explain how you want it to work with you, right? So all those three little pieces, the gold, like the green bright pieces, are the things that are really important to you, and this is why you might be hesitant to restart, right? So wouldn't it be nice then if you could have something like this when we have a new context window? We'll just have only that and nothing else, right? No garbage. That seems really nice. So this is the pattern that enables you to do that. Knowledge document. The idea is just basically go and put it in a file. And then the file has all the things you care about, or several files, right? And then at the start of the conversation, what it looks like is basically, for first of all, so you save it to the file, and then it's easier for you to save or set. And then what it looks like when you start is basically this, right? So you have a knowledge document and a new context, and you say, hey, load the important things, and it loads the important things, right? Very simple, but very powerful. All right. So this is so powerful that actually the tool's starting doing this for you, right? They're like, hey, you don't have to tell us every time that I don't know, your name is X, or that you like that you prefer Java formatted this way. You can just put it in ground rules, and when you open the conversation, it's there for you, right? Think about it this way. I wouldn't put the Java thing in there, but like I think about it as what is the most important things that is crucial to remember, right? That's what goes there. So look, imagine if you're hiking, right? Taking out fire before you continue is kind of crucial. So like that should be the ground rule, right? So and it's like every time you're hiking, every time you open the window, it's important, right? So it goes there. So ground rules. So they're always on. Basically, on the left, this is the context window, right? And basically, you open it, they're there, right? You don't have to do anything about it. Very nice. And then implementations of this are very different, right? So we have like a generic one that's agents MD. Many like Codex is using that, and many other systems are using that. That's Claude MD and so on. And they can be on the level of you as a human, what is most important for you when you code with AI, right? That's the generic one. And also there's ones for the project. It's like in this project, do this, in that project, do that, and so on. All right. So how do you create those things, right? Well, there's many ways. First of all, you can write it yourself, but also you have a genie, and the genie has access to all of this stuff, right? It's not perfect, right? It's gonna put its spin on it, depending on the model as well, and many other things. But it's there and you can use it. So what you can do is like imagine you have this dirty context and some important things. I recommend actually doing it a bit earlier than when it's actually degraded to this degree. But you can basically say, hey Genie, hit save for me, right? And it saves it for you to a file. And now you have it. Now it's actually not ephemeral, right? Now it's a thing that you can point to on a file system, and it's so easy to point to instead of like re-explaining it again. Right? And you can create those from scratch, or you can just go and update those. And there's tricks to this because so Genie is no way perfect in writing this. And extracting like sometimes is lossy and puts a different spin. It focuses on our own things. What I found helps a lot is zooming out. So I'm going to talk about the noise cancellation that makes a lot of difference. But it's pretty powerful anyway, right? The next question is, well, can we put everything in one file? Well, first of all, context window is limited, right? So there's a limitation, there's physical limitation. So it's fixed size and everything competes for this limited space. So what I mean by this very briefly, so we're having the same conversation. Imagine we have a tiniest context window on the planet, right? So we just put it here. And at this point, we kind of reached the limit. So we want to put another message in, right? And first of all, we better have a buffer. So we put it here. And now what happens depends on the tool you're using. So first choice oftentimes, like with Windsurf, for example, was, well, we just drop this stuff that kind of, it's like a ever sliding window, and they don't tell you if that's going on. So basically the earliest messages get dropped and suddenly it forgets stuff that you told it before. Then another one is like compaction, right? So it declares, hey, I'm going to compact. You have some control over how it compacts, but not really. Like you can ask it for things, but like you're at the mercy. So the whole conversation gets compressed and it's lossy. And then another one is like error out. So just no, conversation's too long, go away. All right, ChatGPT in the browser does that stuff. APIs do that stuff because really like that context window thing is actually a physical limitation because basically what it was doing underneath is mathematics of competing all the probabilities and it can only go as far before it goes crazy and exponential and so on, right? So they can't allow it to do it, especially with APIs. So they say, meh, nope. All right, so this is already kind of tricky and not nice, but it goes worse. So um, the agents attention have this thing of attention, right? So it's not universal. And I'm going to show you the anti-pattern distracted agent. And thing is, like people don't see goodness. Oftentimes, people don't see the focused ones because they don't work in this mode oftentimes. And it's been very, very powerful. And I think I got lucky to see it. So distracted agent, basically, I have these rules in my CloneMDs and my ground rules. Since forever ago, first one came from Elizabeth Hendrickson. Be very honest to me, right? Tell me is something I need to know something, if I don't want to hear it, right? Really, really powerful stuff. I've been running with it for a while, and then I got creative, and I was like, oh, what about I actually ask it to be proactive and like tell me warn about like when I'm messing up before I mess up, not after, right? So I put it there, felt very smug, and was waiting for it to hit, and I was waiting for a long time. So how I was working at the time was this. I basically had a cloud code and I was doing everything in this one window. So I've committed, I've done other things. So and I say, hey, commit, it commits, and it's very nice, good message and so on. But basically what I was dealing with is a generalist agent. So the agent that does everything, right? So for example, like there's like my project, it's coding pieces, like everything. And for example, this is my commit rules in there. All right. So I tell it to commit, it commits, and it does everything else on top. The thing is, like, you can also do this, right? You can also just ask it to do one thing. And surprisingly, when you ask it to do one thing, even if you like the context size is the same, it's often much better performance. I find it's behaving much more because it's only worries about this one thing. Right. So basically, the generalist dilutes attention across everything. You get shallow focus and it gets fixated on wrong parts. It just is not as good. And I saw a specialist for the first time um, basically, and it actually made a really big impression. So a lamp has limited focus, and I saw the focus station for the first time. So this button focus station. So basically, when I saw it the first time was this. I started actually spinning up the committer in a separate window. So I had this main clock code in this window on the left, and then I was like, oh, maybe I just spin committer on the right because I started to get aware of the limitations on the context, right? And I tell it to commit, and it's like, oh, committed, and it commits it with my rules, so it's nice. I switch it to this mode, and it's kind of working in this mode. So basically both of them have my ground rules, right? That they're looking at my ground rules, and they know that thing from Elizabeth Hendrickson, and the productivity rule isn't there. So um, basically this is what it looks like right nowadays, right? So I have basically a giant ghosty window and a bunch of tabs here. And like I often have a left window with Claude, right window with Claude, where they criticize each other and like they work together through me usually. I don't have them communicate to each other right now. But I also have this little committer. So this is a little committer on the side, right? And I say C and it commits. So pretty nice. And I also have bash stuff and it like splits a lot. But this is roughly like what my working thing looks like right now. All right, and so what started happening when I did this is my committer started worrying me about the mess ups. So basically, the first thing was like, "Hey, you're about to commit your whole node models directory. Do you mean to do that, human?" I'm like, "Oh, wait, thank you, no." Let's not commit that. The thing is, like, James Shore has a thing to say about that. It's not always a bad thing. But at the time, I didn't mean to do it. It was an agent really doing it, right? So I was like, oh, that was so helpful. Thank you. No, I didn't mean to do that. Let's not do it. And then another thing was like, hey, dummy human, you're like violating your own like naming conventions. Did you mean to do that? Right? And so on. And like there was some weirdness with PDF file. Did you mean to stage or not stage? You know what it's saying? Like the models are getting better. You know what it's doing now? It's warning me about bugs, right? It's fixing it, like it's finding bugs. I'm like, hey, I just reviewed the thing that we're about to commit. There's a bug. Did you mean to put it there? How helpful is that? I have other ways to find bugs, but basically, like this is what we're dealing with. And so, the thing is, this is a specialist, right? This thing is only like focused on this one thing, and it also knows that I want it to be proactive and it has the capacity, right? So it has the capacity to pay attention to all the ends that I ask, and I don't ask it too many ends, so it can do that. So that's what good looks like, and I think many people don't see the good because they just used to working with this distracted agent all the time. So super powerful, really recommend when it's important. Is it always? Maybe not. Like I'm not perfect at cleaning my context and I have reasons to not. But when I need this important, like it's really important that you do this well, I would do it in a specialist session that is dedicated to only the thing I'm asking you to, right? And so much more narrow focus, much better instructions following, and much better results. So, but it also means that anything that you put in your context that's not being followed is actually actively harmful. It's not just noise, right? Just noise. It's actually harming your performance quite a lot, and people don't notice. So, pretty important. So, how do you basically just give it the pieces that it should care about in the moment, right? So, the pattern that enables it is references, right? Basically, think about it as build your library of things you need to give it and give it to it in chunks that you need to hand it to. So it looks like this. Basically, we just talked about ground rules, right? Ground rules are always on. They're always in context. You don't need to do anything about it. But there's also things that I care about very much in different points of time. So for example, there's maps, right? Hey, like there's test station there. Please run tests with that. And also there's a bunch of things in my project, here's where they are, so it doesn't grab and like, oh, where am I from scratch every time, right? Then there's guides, so like, hey, I like my code style this way, for example. And then playbooks, I like my TDD process. So it's a playbook, follow the steps, do this, do this, do that. Makes a lot of difference because some people are like, oh, go TDD, and they're wondering why it is not working. Basically, like it's to-do list, right? So playbook is also a to-do list, really. But to-do lists in general are super powerful, right? That's like a giant difference. Like if you, I see Throsh noting in the audience. Exactly. So, like if you put it, like if you just throw things at it, and if you put it in the list and ask it to do it in turns, much better instruction flowing. And then scratchpads. So I think about it as it's really helpful because AI is noisy and there's a lot of things going on to kind of dedicate it an area of like here's the garbage stuff, right? So here's a like here's my scratch pads that I know and this is fleeting. I sometimes put it to git ignore and also I sometimes let it like loose in that folder. That's very helpful for to investigate like fleeting stuff. So kind of scratchy like territory where we scratch and then we throw away and we don't even commit this stuff. Right. So so there's ground rules that are always on, but there's also things that are pulled in, and they're pulled in as needed. Right. I pull them in as needed. What it looks like when I work with it is this. On the left, there's a context window. When I just started the conversation, I started working with it. Right. So we have so this is me talking to it, and then suddenly I need nullables from James Shore. Right. So I have the nullables document already. Um, it needs some love, as I realized, but it's there. And I pull it in and ask, hey, here's how to do nullables. And it goes and pulls it in, right? And then I do something else. I need something else. Maybe I need my TDD process. Hey, here's my TDD process slash command, right? Do TDD. Or maybe I just do maybe it starts to invoke a skill, which we'll go to in a second, right? So it pulls it, I pull in my TDD process, for example, right? And then something else, and then test plan, right? Maybe let's test now, and so on. So this is roughly what the conversation looks like. And the next conversation will not look anything like that, right? It will be very different. Here are only the blue stuff is only the things I needed when I needed them. So basically the idea here is start collecting the your knowledge library, right? Start pulling in things you care about that you have to, especially things that you repeatedly tell AI to do. Put them into files. Now they're pointers, right? And that now you can enrich yourself, makes you more powerful. And basically, how do you decide what goes into which file, right? So the idea of knowledge composition is basically that. So think about it this way, very, very simple, right? So we have a context window. We have, say we put everything into one file. So we create project MD. We say, hey, project info goes here. Also throw in the Python style guide, JavaScript goes there, and both front end test plans, right? What are your choices at this point, right? The only thing you can do with that is like, hey, here's the file, right? And you have to kind of just pull it in the whole thing, right? And but the thing is that you only cared about front end plan right now, right? So um, you can't pull in and out individual pieces. So basically, if you do the other thing, right? So if you just think about what you might need to pull in separately for different tasks, you just pull in that when you need to, and like just this bit, and everything else is not in context, not garbage in your context. So that's how to decide, right? What do you need to pull in individually? Pretty straightforward. Let's talk about skills briefly, right? So skills are really like I don't have a pattern skills because I think this is more fleeting than that, although it's really, really powerful, right? But really, it's a composite thing. So what it is ground rules, really, plus references, plus progressive disclosure. And progressive disclosure is just a very fancy way to say that the genie pulls it in as needed, right? Instead of you pulling it as needed, genie pulls it in and make decisions when you need it. That's all it is, right? So, and what it looks like is this. So there's a skill.md file. This is a file, right? This is a file about you how to do UV stuff for me, right? And it has several components to this. So first of all, there's this bit that has this called front matter, and many people mess this up quite a lot. This description is very important. This is for the genie to pull in. It makes this decision. You can also invoke skills, but for the most part, it's for the genie to make the decision. So it's written for the genie. It doesn't need to be, an Odyssey or something giant. And some people like that actually makes it invoke it much less likely, right? If you distract it too much, like, oh, let's be thorough with this description. Don't be. Use this one, right? And then, so it has references to other things. So this skill MD is an entry point, right? At this point, it has references to other things. And what it is basically other files, right? So it points to like, there's a scripts MD, project MD, and also like it has tools so you can have a linter if you'd like, well, like linter sage or something like this. That's just an example, but that's the idea, right? And what the working with that looks like is this. So first of all, we have ground rules, right? And then we have this front matter. This is the only thing you're paying for. That top little bit. That's why it needs to be tiny and focused, right? This is what you're paying for every time just by having the skill, every time on every conversation. But then you start talking to it and you're like, hey, I'd like to pull, like invoke skill MD, or the genie decides that it needs to have skill MD, right? So, and only the skill MD is pulled in, right? And then the genie kind of reads it, and as it reading it, it's making decisions what to pull in as well. So, for example, I'm like, hey, I want to do scripts with it, right? So UV scripts versus UV projects. So it goes and pulls in UV scripts. That's its decision, right? But it pulled it in. And then you do something else, you work with it, and maybe now you're about to commit and you need to run linter, right? You say, hey, run linter, right? Or the genie is like, oh, I need to run linter, but I have the skill in me, right? And I need to run linter. So it pulls it in and runs it. It uses the tool and so on, and the conversation progresses. So basically, this is what skills are about. They're super powerful, obviously, really, really good, but yeah, that's how they work. Right, and the front man is always in context. The skill MD basically starts behaving as ground rules when it pulled in, right? It's not always ground rules, but it starts to be this ground rules that's always in the context. So that also means the skill MD needs to be tiny or smaller, right? To make that decision, to not overload. And then the scripts and linter basically and everything else you put there, references are pulled in as needed. So like compartmentalize. That's how to really write good scripts with good skills. All right. So we talked about how AI can't learn and there's a concept of context rot. So we need to manage context. We can't just put random stuff in there. And there's the easiest thing you can start with is instead of putting things to ephemeral conversation, put it in a file. And then some like you get to those files by asking Genie to extract information oftentimes, or you can write them yourself. And there's some things that are so important that they're kind of ground rules for AI um, that are powerful, right? And then the Genie is also getting distracted pretty easily by when you ask it a lot of things. So there's a concept of attention, and the focused agent is actually really, really powerful, right? And then the idea of reference documents, right? So how do we focus? Well, we give it things when it's needed. Reference documents are the tool for that, right? And you figure out how to chop up the knowledge by doing knowledge composition. So one of the last bits in this trail is basically uh, the last problem is that AI is really, really noisy by default. So basically that's a big problem in general with when you talk to it, but also it's a giant problem when you're trying to do to write documents with it as well, and that makes a lot of difference um, in the documents. So what does it look like? So I started to learn Rust, right, and I was like, asked it to do the project for me, and asked it, hey, can we create some like some sample project, and I poked at it and I was looking at it and I got curious about what is this cargo tom file? What do you need it for? And gave me this. Right. So and when I see this, I go like, oh, this is a lot of text, but I don't even care about this. Oh, I don't care about that part yet. I don't care about this yet. I really, really don't care about that part. So my next move, pretty much universally, is like much more succinct, please. And so succinct means terse, really short, TLDR, whatever. Some people like caveman. I haven't tried caveman, but I'm against the idea, but I may be wrong. I might actually try it. But the idea is basically really, really short, right? Don't allow it to give you sheets of stuff. So and this is what it gives me, right? So oh, cargo tone file is a configuration file. Oh, it's like package.json. Okay, I understand. I don't know. And it has metadata dependencies, build settings. Okay. Oh, you can't build without it. Okay, that makes a lot of sense. So thing is, um, notice how the level of detail here matches the level of my curiosity, right? And this is just noise. So many people allow it to overwhelm you, but like think it's very, very not helpful. And I think people just don't realize that they have an option. You have the option, right? And so this option is basically you have control, people. You have semantic zoom. So this wasn't something that was a thing like more than 3 years ago, but with AI it is a thing, right? You can imagine like with images you can zoom in and out. You can do the same with text on the level of information, right? So And this is super powerful. To zoom in, you say, hey, tell me more about this thing, right? Let's go into details about this, and so on. And then zoom out is basically, no, make it shorter. I'm also saying TLDR, right? And I actually like default to zooming out, the hell out, because that what makes it manageable, right? So the zooming in deepens your understanding when you have the curiosity for that. And then zooming out makes it really risky. And so this is really, really powerful. And the pattern that enables is noise cancellation. So let's zoom the hell out by default. So force the sickness pretty much in the knowledge documents is especially powerful. So like this is what makes the difference between maintainable documents in my projects and not maintainable. I zoom the hell out because AI would want to be very helpful. You want to put all the noisy details. It will rot in time. It will be crazy to look at. You won't be able to manage it. AI won't be able to manage it. It will degrade very quickly. So zooming out helps a ton, and it can always be expanded. And Git is your friend. If you value, like we're all kind of hesitant to delete, but like just rely on Git for this stuff if you need to. Plus, you can regenerate it every time, right? And then it also forces it in responses to you because people, I'm amazed at people who read that stuff. Like, oh, tell me what to do. And it gives it like 10 sentences, like, oh, thoroughly like reading. You know, you're working with a token machine that can generate any amount of text on demand, right? Why are you reading garbage stuff? So tune in, zoom in, like I think about it like code, talk to me in gems, not in like random stuff, right? Like I don't need helpfulness. I need the gists of things. Makes a lot of difference. And then delete mercilessly. Like Git is your friend, like I said. And then I like this temporary throwaway stuff. That's why I like it. Because if you think about it, like one noisy human with a noisy AI is pretty bad, but imagine the whole team of them. That gets horrible pretty quickly. Don't do this to your teammates, right? Throw away docs. Don't save all the garbage. Be very careful for what you save, really, or just do a cleanup regularly, right? So I really like those temporary things. So yeah, and so again, the noise cancellation is actually not just like be terse. It's also let's look at high level of information, right? You don't have to like it's like what information would you like would be the most important bits that you need. And for example, here, and I really like so I really like asking for kind of poking at things quite a lot. So that's why I'm showing this. So this is me asking, like, this is me asking it about Kafka architecture. High level, show me draftly how Kafka looks like. And then I go in and ask specific questions about specific bit I care about next, right, and so on. But it gives me the information on the level I care about, and ASCII is nice because you don't have to go to a different tool to see it. That's why I like it. I'm in text. It's showing me pictures and text. And kill me now, I won't edit this. Like I would make this myself, but I will edit it, right? I can actually give it back. So I like it. And and what I was talking about, like, okay, so preventing from overloading and making docs manageable is important, but you can also do it in text by zooming the hell out. And the way to do this is basically write tests on the high level domain level, right? Not the unit tests, but maybe the domain tests, the tests that answer your question, is this working? And this makes so much difference in tests because now you actually like if you read the write the tests, the acceptance tests for the system, right? On the level of like what AI or humans used to write it on, it will be really hard to see you want to write it on the domain language, and it's much easier now to get to the domain language yourself. So if that, for example, has examples of those kind of tests with approval tests that are very helpful, evert or doc, right? And you can also do other things, like you can debug on this level, which is kind of crazy. So if you like vibe code something and you don't know what to do, like you don't pull on the debugger and figure out like the code on the small things. If it's something that you actually don't care about, right? If it's not long-term thing, you can actually talk to the genie and like, hey, let's talk about something. This is what's happening. Let's think together. And then show me what's going on in the system high level, zoom out. And when you poke at it, it actually often finds its own problems much easier. All right, so that's the idea. The last bit in this step is so this idea of external context. So basically, the idea is this. So you have a context window where you have different things. So say you have a big interaction with it, and there's this big piece, and maybe this is a side thing. So this is something like, oh, you run into a debugging session, or like, oh, there's a tool that needs to installation and so on. So you can do it here, but also like the patterns that getting available everywhere pretty much is this. You can just take this thing is and take it out of this context and do it elsewhere, right? And how it looks like in practice is different. So it can be, say, it can be like a separate Cloud Code session or some Codex session, or it can be like a sub-agent, or it can be something else, right? But that's the shape, right? So don't do this in there. Do it by interacting with another thing. Or you can, if it's a sub-agent, basically it looks like this. Here's the thing, and then the conclusion, and we only pull in the conclusion, right? So we're not paying for the whole giant thing. And then you continue conversation. And now it's much less distracted, very, very helpful. So that's the idea behind it, right? So helps with context as well, quite a lot. So that's the idea of context management, the big parts of that. So and to finish up this branch, basically AI is really, really noisy by default, right? And you can zoom in and out. You have control. You don't have to take whatever it gives you, right? And think about it like, oh, I can ask for things that I need. And then noise cancellation by default, really, really helpful, super powerful. Highly recommend. And external context is also helpful to avoid distractions and to manage context. All right. So this is the first pit stop, and I would like to ask if you guys have any questions.
I know the chat has been very active. Certainly something to look at after the fact, Lada.
Yeah,
Anyone have any questions? Please speak up or raise it in chat.
Actually, I have a possibly dumb question, which is my favorite kind.
same. Heated.
Um,
I bet it's not dumb.
so I'm thinking about what you said about editing the context like mercilessly, but I feel like that's really competing with the the way that context is managed by the LLM, where basically it's additive only generally as the conversation goes on. And I thought of
Hmm.
agents as being kind of like a subroutine call, maybe, or I mean, a skills, excuse me, where the
Hmm.
thing runs off and does this one thing, but it ends up
Hmm.
pulling in some additional context. But what if it's not needed afterwards?
Exactly.
So, and then now it's just contaminating your context for later and taking up space that it doesn't need it anymore because you just finished it. So,
Hmm.
is it really weird to think that what if you just started over, you basically subtracted that part out after and start off
Uh-huh.
a new one, a new basically discussion, but with everything else except for that, you just finished that basically that skill,
Hmm.
but you don't need it anymore. So can you just like start over but leave that part out and basically leave all your start over
Yeah,
after every skill essentially, and then it's like a subroutine call just pulls it off the stack kind of when it's
I
done.
think you can do it. Yeah, I
But
can do it. So I've been talking to Arlo Belshi and he has been playing with that actively. So what he does is basically he kills the session, right? It
okay,
goes in and edits it because really what the memory is on the file system, right? So it's
yeah,
on your disk. You can go and
yeah.
edit that stupid thing, cut it
Mhm.
out. And I really like, so Arlo did an amazing talk on craft, and the ideas there was uh imagine humans. Humans are in the world. We don't really control where we are and so on, but with genies, we do. We
Mhm.
can not give them all documents and we can alter their memory if we'd like. Right.
Yeah.
So what he goes in and like he shuts down the session, cuts down the stuff he doesn't want,
Mhm.
maybe puts in stuff that he does want that didn't happen, and then launches the session and it doesn't know. Right. It's like totally like this is what happened. So I kind of really want to do this, what you're talking about. Like I've been actively thinking about it. I really want like those kind of scissors, cut it out, or edit or add.
Right.
Would be
And
nice.
just to be clear, this probably wouldn't apply in places where you're using a focused agent because they already have their limited context. But where you're using a general agent that's dealing with something that
Yeah.
is like kind of like cross the whole project, touches a bunch of different things, needs to know the full context, does a special skill, but then you're done with it, so you don't need it
I don't
anymore.
want this anymore. Yeah, I know,
That's
I know.
right.
I want this control. And the tools
Okay.
also are kind of doing this. So Cloud Code started kind of compacting not compacting, throwing away, I think, their tool calls recently, like maybe half a
Yeah.
year ago. I think they're starting doing that. So they're aware of that. But like I'm kind of upset that we don't have this control over what you're talking about.
Well, I
Like I
think
really want that.
it's not in their interest because they want to have more tokens, right? But
I
it's
don't
in
know.
our
They also
interest
are
anyway.
overwhelmed.
All right,
Yeah.
thank you. That's a good answer. Thank you.
Thank, thanks for the great question. Hey, Jay.
Hey, Lada.
So,
So you talked about using subagents to control context, but it sounds like you do that manually, like you go and put a new prompt in a subagent, or the main
mm,
agent, you say, right now, make a subagent. Do you ever set ground rules that say, like, whenever you're doing this kind of thing, that should go to the
mhm.
subagent, and then it's kind of out of your hands and happens automatically?
I don't do this. I know Yvette does that, and there's definitely advantages to that. Why don't I do that right now? I think because I almost aware of the lostness of that process. So when you give things away to the agent, you can add the mercy. It prompts it, right? And
Hmm.
whatever it told it to that sub agent is like, can I add this mercy? You can contrast this and kind of control that by having this main agent also check the work, right, of that thing, which is very helpful. Um, but I don't know. I think I need to play more with this. I don't do this, but absolutely what you're talking about is possible, and many people are doing it, I think. I think I'm balancing things quite a lot, and I'm trying to understand why on earth do I not restart the whole context every time? Because I don't. And there's
Hmm.
reasons for that. Like this big session that I have is actually very valuable, and maybe I'll code in another one, but I want to have this long context too. It's valuable to me as well. It's a balance thing, and I think it's like right now I don't have a very good articulation for why I think I sometimes don't do that. Yeah.
Okay, thank you.
This was my
Thank you.
same question, actually. But I think I think you actually summed it up pretty well in that, like my question was going to be around when do you, like for a specialist, where I want to do your like commits. You want more control over that. You actually want to see what it's returning, which a sub agent, it just kind of does in the shadows and only talks to the other agent. I mean, you can look at the output, but it's another key press and we're lazy. Um,
Mhm.
but I think I like that you call out you just lose control because I think that is a good succinct way of calling that out. So
Yeah. Yeah, unfortunately.
yeah. Right.
Hey, Michael.
Uh, Hi, can you hear me now? Am I off
Yep.
mute? Yeah, this is the second time I've seen this, and I get the same issue. Thank you for taking your year and a half, and condensing it into one talk. I want to expand it, and maybe this is good for the end. But how do you take this talk and break it into little pieces and practice it for the next year? So you took a year to make this. How do I take this and do it in a year? Any thoughts on how to practice?
Wait. You want to practice the specific bits? So like you want to practice the specific items that I talked about? Like you want to make practical trying it out?
Thinking like of a gym of like you want to work upper body or lower body. Do you like
Mm-hmm.
work number 8 by itself or work number 6 by itself and then compose
Uh-huh.
them?
Actually, that's a very the problem I'm really facing right now because I'm going to be at Socrates in Germany in the end of August, and I kind of need these practical things that you're talking about. I think I'm gonna do like a workshop and figure out how to show this bits. But I agree that I think they need to be. It's a good point that you brought. I think they need to be atomic, right? So I need to be like exercises for this bit. That's actually very helpful to me. Thank you.
So
Yeah, I don't have an answer right now, unfortunately. Uh-huh.
so like when you're kind of like context management, do you launch into these and say, well, today I'm going to work on these 3 skills and not on these 3 skills? Because
I think you can keep the others in mind, but focus on the specific thing. So it's like a kata. I like that idea. Yeah,
yeah, thanks.
yeah. Don't have anything better right now. Sorry, but I'll think about it. Actually, thank
You
you
do.
for
You've
this
been doing
question.
it for a year. So how do you do it? Yeah,
Fair. I
thanks.
think I don't need to teach people every day, like all the time, unfortunately. But yeah, I think it's tough. That's to be important. Heroes.
Thanks.
Lots of
Hello. So on that, I think what I've started doing recently is after I have a conversation, and if it does or it doesn't work well, I'm thinking about what could I have done better
Uh-huh.
with the
Ooh, yeah.
LLM. And that's kind of a way to go back and you go like, okay, these concepts, what could I have, if I, do I need to pull some documentation into a new file? Would
Hmm.
it help me if I tried this? And so I
Right.
think part of this deliberate practice is doing um, is thinking about it and going like what worked well, what didn't. And so
Hmm.
you're not just kind of like,
Yeah.
yes, you were trying to achieve a task, but then back up and think meta, like, okay, how can I improve the way I did this so that I will do it better
Hmm.
next time?
Hmm. I love that. I think that's a great idea. And also I think some people are actually doing like, wait. This thing that just happened, let's pretend it doesn't happen. Wipe it up, fix the instructions, start again. Yeah, absolutely. That's a very powerful technique, I think. Thank you. Hey, Matt. Wait, you muted.
Hi, this is great
Hey,
so far. Thank you, Lada. I wanted to build
good
on
to
what
see you.
Rose was saying. One of the things I tend to do is have like a mini retro with the agent if I've done something meaty in a session where I'm like, oh, that's where I think we've learned something that I want to keep here. And maybe it's like, let's extract a skill for how to do this next time. Or
Yeah.
is there a knowledge document that we wish we had that would have
Hmm.
helped us in this? Like, what lessons can we learn from this? Have a little retro with the agent and work with the
Hmm.
agent to write down the things that you want to keep from that session that are going to be like reusable in other sessions.
Sure. Yeah, that's amazing. That's what I do. Like when I say extract knowledge, basically that's what I mean roughly. Like, oh, we did a thing. Now let's take it high level. Like think about what happened, retro. But like I think it's an excellent point to
I
kind of
think
have that
about it
step in mind.
like like continuous improvement, like Kaizen. So it's
Hmm.
like meta level of the, it's not the work, it's like retro work. So
Hmm.
I'm trying to
Hmm.
capture, and even if I'm just
Exactly.
capturing, oh, this was difficult, this was frictional, I'm not sure what I'm going to do about it yet. Like I might even just capture that as a document
Yeah,
and keep it somewhere and then think about
exactly.
it later.
Yeah, and the thing I think here that comes to mind is like you need to be there doing it yourself because you need to be very involved in that process because if you just let agent to improve themselves, I'm very skeptical of that stuff. That dumb will
Yeah,
absolutely do all the not important bits in there and all the detail. Yeah.
I find I spend more time now reading these like reusable prompts, like skills or maybe even like reusable knowledge documents. I spend more time reading them than I spend reading code because they're like the
Mhm.
seeds that are going to generate the code, and I want them to be really tight.
Exactly. Exactly. Thank you for that. All right. Thank you very much. Let's continue maybe, and we'll have another pit stop, and we can hopefully have a conversation at the end as well if we have time. So let's go on. So, all right. So the next problem with AI, the big section of the problems, is that AI is non-deterministic, right? So with code, it's very nice because it's like you know what's there, you can read like no surprises. With AI, it's non-deterministic, and that causes some problems, but also it's an opportunity, and it's a big one. So, but to speak about the problems, right? So basically, the first pattern that helps here is this knowledge checkpoint. So just make it very easy for yourself to roll back. How do you roll back? Right. And the idea here is basically this. So imagine you worked with AI. So you just planned something with AI for a long time, right? So you spend 30 minutes talking to it. And then if you just let it go and implement that directly, what often happens is it fails or it gets stuck or something else. It gets stuck less now, but it's still happening, right? And now you can like, oh, now you need to roll back, and it's annoying and it's hard, right? So, oh no, I have to re-explain everything, right? So what you do instead is basically instead of the scattered knowledge in the context, in the fleeting context, and having to have to get to the same state, what you do is you basically introduce a checkpoint before the implementation, right? So you have this several steps here. And first of all, you're like, hey, save it into Markdown. You read that Markdown carefully, make sure, or you save it yourself, and then commit, right? At this point, it's saved, and now if it goes implements it, like you have the knowledge checkpoint, right? You can roll back. So protect your time and investment in planning, right? And it makes it easy to roll back. And now, like, if you need to roll back, it's a nothing game, right? Hey, new conversation / new conversation, new context. Read this file and go implement, right? All it is. So restarting becomes so easy and straightforward. So an example, for example, on Hack for Good, how we did. So we already had a feature on the right. This is a project document, and this is a tiny project. And so we go and edit this file, or we ask Genie to edit it and say, hey, we want to add support to keypads, right? So now we want to control how we count, not just by clicking the mouse, we also want keypads. Here's a feature, go implement, right? And now we have a knowledge checkpoint. So it's a small one, but like if you get into a habit of doing this with everything, you will not be burned on the big one, right? So, and oftentimes what this thing will do is like, oh, sure, human, I will go and implement it, right? So I have to often say, oh, no, stop and document it, right? Especially Claude is so eager to just start doing stuff. And so that pattern is pretty powerful and enables several things. One of the things is parallel implementations. It makes parallel implementations much easier because, and the idea of parallel implementation is basically also nice because, well, non-atomism is problematic, but also it's an opportunity. It's a giant opportunity, right? And you can do so many things with it. So, okay, so what does it look like? This is a kind of silly example. Basically, imagine I got a new puppy and I'm thinking about names with, I don't know, with AI as you do nowadays, right? So and I'm like, hey, give me a new ideas for the name of my puppy, and it's like, well, it gives me some of this woofy, but oh, I like this waffle. It's kind of cute. All right, but now that I saw waffle and woofy together, it gives me a new idea. Ooh, maybe it's a nickname, woofle, right? So notice how I got a new idea by seeing things, right? So this is kind of, it enables you to combine stuff. So it shows you more things. Showing those new things is cost zero. It's so easy to generate that stuff. And then suddenly you get a new thing, right? So that's the idea. And you can do this with code too, right? So with code, what it looks like, so this is from like, I've been coding with somebody on Big Agile. And we did 3 implementations of Ricochet Robot just for giggles because I was showing how I code with AI, right? And it created 3 things. The middle version didn't even work, but the other 2 did, but they worked differently. So this one actually, it produced a better labyrinth, I think. It doesn't have these dumb things like this is a labyrinth wall and a wall, and so on. So I like this labyrinth a bit better, but I also liked this one and it moved better, right? Wait, I have code. I have a genie. I have 3 places. I can say, hey, Genie, steal this feature from there and borrow this feature from over there and combine. Right? Very, very powerful. So you can steal both features and also designs. They're so powerful in design. So try design several ways. It gives you ideas. You're like, oh, I like this. I don't like that. Borrow and combine. So really powerful pattern. So parallel implementation. So now you have checkpoint, right? So you're at the point where you have that checkpoint. You did the thing, like this is what I want to do, but I'm not doing it. I'm doing it in 3 pieces, right? So now you're branching out and say, hey, do it 3 times. And several things here that are good. You can also do it with Git work trees so easily, but like several things. First of all, if you really, really care that one of the results succeeds, period, right? That's was a way to do that to save time. A little bit you pay in tokens, but you save time. One of them probably will succeed. And then you can borrow pieces. So super powerful. Can do so many things. So that's the idea of parallel implementations. Really, really good with designs and giving you more ideas, right? And then the float deterministic pattern, the next pattern is about using the right tool for the job. So what I see a lot with AI is people are basically pulling, like now that they have AI, they just start using AI for everything. And it's not really a good idea. So what I mean by this, so we were on Hack for Good last year with Paige and Steve here. And basically, we were trying to show how to do Agile well in 3 days. And we also trying to help the like local nonprofit organization to actually like help them, right, with software, writing software. And so we're developing this thing on the left. It's a counter, but we also wanted to, when people wander into the room, for them to see what we're working with, so they can pull out the phone. It's on the monitor, and they're like, oh, okay, what is this? Thing on the left is the screenshot of the application at current state, right? We want to update this often. So what do we, how do we create this thing? It's a simple example, but it's also like something that makes a lot of difference if you do it on everything. So we didn't. So what we didn't do is we didn't go to it and say, "Hey, take a screenshot of the current page using Puppeteer." Right? We could absolutely have done that. Do you have any doubts that the second time we took a screenshot, it would have been a little bit off? Because the genie wouldn't do the same thing the same way, right? So it's unreliable. What is reliable? Well, code is pretty good, I heard, right? So what we did instead was said, hey, Genie, go write me a script to take a screenshot of the current page, right? And now you create yourself a tool, right? It's there in the bash. It's capture screenshot, and the way you ask Genie to take screenshot is invoke that. And that's reliable, right? So the Genie can also invoke it for you, run that script, and it automatically updates it. So basically, use the right tool for the job, right? Don't just use Genie for everything. It's really, really powerful. So we're talking about non-determinism, right? And this is like both a problem and actually a very good opportunity, because first of all, well, it's a problem, right? So you know that it's not going to be reliable. Well, don't trust it with your valuables, or at least don't like save a checkpoint before you start doing that, right? And then parallel implementations, use that for good. Think about it as throwing a die, like, right? If you want a specific outcome with non-deterministic thing, how do you get to it? One way is to throw a lot of die, right? And then you might get some things, pieces that are valuable. And like this is like not a full die, like a quarter of a die, like you stole this part of idea here and so on. But still, right? More options. And then a full deterministic, basically, right, use the right tool for the job. All right. So another thing that AI does is this unvalidated leaps, and I've seen it with humans as well. So the idea is this: basically, you do something that is a iterative process. It takes several steps, and say it fails at the end, right? And you go to Genie and like, hey Genie, it's not working. Can you check? And it's like checks here, checks there. Maybe it even checks here, but there was a wrong assumption there, and it didn't check that assumption, right? It just went glossed over. It happened to me. I had to actually stop it and like, no, let's check the result of A, check the result of B. Oh, there's a problem. Expectation was wrong. And I see it with humans as well. So what I as a young developer, I can tell the story when I just started being a developer, really. I was working with somebody in PL SQL, and she basically wrote the whole thing without launching it once, without starting it once. And I was like, oh wait, you're making so many assumptions there. Do you know that this function returns this thing? Do you actually know that this is a Boolean? Is it? So it didn't even compile when we ran it, right? So this kind of, because there's a lot of assumptions that weren't true and you didn't check, right? So, and the AI does the same thing. So what helps here is slow down and validate each step. And then I really like predictive TDD with it, right? So I make a TDD. I have TDD, so unit tests, and I also have BDD tests high level. The Genie allowed to do the tests and edit the tests. And what happens with predictive TDD with humans is like, so you write a test and then you predict, is it going to fail or succeed and how? And this is a way to check your mental model against reality. And it gets you surprised and wakes you up when it fails, right? And I find that it does the same thing to the Genie. It starts paying more attention. It's not like in a sloppy thing, right? Really, really nice, really powerful. Kind of force it, go back to reality as often as possible, right? That's the idea. All right. The next problem with AI is it struggles under complexity. So the way to deal with this, right, is this chain of small steps. So you both heal how this thing take many more simple steps. The idea is basically if you take a giant leap, right, you have zero control what's inside, right? Instead, what you do is take a little step. Do you need to adjust? Take another step. Do you need to adjust? Is I'm going good? Right direction? And so on. So you take a lot more steps, much more control, much more feedback, and you don't get the unvalidated leaps where the result is completely like you went a completely opposite direction of where you wanted to, right? Nice. So what it looks like in practice is like, so this is again from Hack for Good. This is a screenshot of basically we were developing this website in 3 days, and we released a lot every day. And we quickly discovered that we need the feature here is the version number, right? So we quickly discovered that we need a version number because when you deploy a front end and we test a feature, it's really not clear. Is the feature there and it's not working, or is it actually not there because it didn't deploy, right? We needed to distinguish. So we needed a version number. How did we get to this version number? And by the end, it was like 51, the end version. So how do we get to this? The one thing we didn't do is we didn't go to it and say, hey, show the version number in the config and always increment it when we make a new feature. Surprisingly, I just saw somebody do it on my project. Well, it's violating a flow deterministic. Do you have any doubt that the AI will forget sometimes? Do you want your version numbers to be unreliable? I don't. So this is bad. Don't do that. What is good? Well, again, I heard like Git hooks are pretty reliable, right? Way to commit something and increment, right? So what we did there is basically rely on Git hook, right? So, and you don't always want for version numbers to rely on Git hooks. You can do it in the pipeline, right? But that's the idea. So we went here and said, hey, can you just make a version number? I did it in steps, right? So first thing is I asked it to just hard code this version number. It's a hard code variable 001, and I just show it in the front end. That's all, right? Hard code thing. It wasn't there, now it's there. Nice. Added a number, small change costs 0. Then create a script that ups at 1. Like every time it's run, ups at 1. Simple, simple, simple. Costs 0 again, right? And it goes and does it. And then basically we have a new script, right? A new tool. And now we say, hey, implement a Git hook. So now we add, it's impossible to not run when you commit, right? And we wanted to kind of up it when we commit, it was important to us. So it goes and does it. And then there was some issues. It's very nice at figuring things out. So it goes and figures it out. And now we have a thing, right? Took us almost no time, a very reliable thing. So we went from hard-coded variable to a script that ups it to 1 to a Git hook that makes it reliable, right? Very simple example, but if you get into a habit of that, that will kind of save you quite a lot, I think, on more complicated problems. So in the patterns here, so this is where we start to get into accords of patterns. I'll show you a few more later. So this is a chain of small steps, little step at a time, only one thing. And then a flow deterministic, right? We're not relying on something that's not reliable to do a thing. Focused agent, we're just doing this one thing and it's behaving better at that. Even if you do it in one context, at this point, it's focused on only one thing. And then knowledge checkpoint, if you wanted to step, like on bigger problems, definitely save it into a file and save yourself the rollbacks if you need to. All right. So that's the idea. So we have this unvalidated leaps that both AIs and humans do. And the problem is like AI doesn't manage complexity. So you have to do it, right? Somehow. And one way to do this is this kind of breaking up things into small pieces, little chains. So you have more control. And then the next thing is fun. So AI slop. So AI slop recipe is pretty straightforward. You prompt AI, you maybe lightly edit it, and then you present it as your own work, right? And the side effect is the common spaces become garbage and people tune out and leave. Not good. With code, it looks like this. Basically, no guardrail, single prompting, and then ship it. Is this bad? I would argue that it isn't, because thing is, what are you doing? It depends, right? Are you doing a tool that will never freaking change on your planet? Please do this. Because if you don't do this, like, if really it's a really fleeting one thing, why are you wasting time, right? It's not important. But with big things, please don't, right? So it's a balance game and it's a judgment game. What is the level of risk? Do you need to do it? But thing is, like, I'm not trying to actually judge anyone here. Like, what I'm trying to say is, don't expect a single pass to produce good code or good anything ever, right? Sometimes it does more of that when I actually do TDD, surprisingly. So I had a very interesting recent experiment. But still, like, it's just not usually happening, so don't expect it. So what can you do immediately to change the outcome quite a lot and make a lot of difference? This first part is a feedback flip. The idea is basically this. So you can do it in two variations. First variation is you have two coding agents. So I showed you two windows on both sides, right? This one is your coder, for example, and this one is your reviewer, or whatever you would like to call it. You tell to the coder, hey coder, go implement it. Usually in a file it's good, right? Because now you can also tell your reviewer, hey, there's a diff in a file. Can you check this stuff? You don't have to re-explain this to a reviewer too. You save some time, knowledge checkpoint, right? And then it goes and implements the improvements, and the code and the reviewer cross checks again, right? So you basically just this little bit makes a ton of difference. So it is able to find these problems a lot. But what is interesting is, like, there's a second variation, and I do this a lot as well. So second variation looks like this. There's a coder agent, and that's all you have. Hey, coder agent, go implement. Hey, given that thing you just did, can you find all the problems with it, please? And interestingly, it's not self-conscious at all. It actually goes and freaking tells you what it did wrong, right? Very happily. And then you say, apply improvements. And thing is, people think that AI cannot write good code because it was trained on a lot of bad code. Maybe there's a gist of truth in that. But also, like, interestingly, if you ask it, hey, what are all the problems in this code in this dimension or that dimension or in general, it'll often tell you, right? Why doesn't it do this? So I actually don't know, but I think I have a theory, and my theory is basically, right, why does it work, right? Interesting. My theory, I think this is a focus problem. So I think this thing has only focus for one task every time. So you ask it to code, it codes, it works, right? Nice. It doesn't have capacity for anything else. It's like, imagine you have a 4-year-old and you're like, hey, do this thing there, and also don't forget to that. And so, like, it doesn't even work with grown-ups, right? So definitely, and the same thing with the eyes. So I think it's just like, it's unfortunately named, it's called AI. So you kind of think about it, oh, it's a whole brain. I think we're trying to build a whole brain and we don't have it yet. And we have thoughts that may be good at one thing, if that, right? But we have control. We can actually improve it with this kind of feedback flips. And when I give it another task, it has a new task and it's good at that. So now the task is to find issues, and it does. Like I'm refocusing it. So that's the idea of this panel, right? But then can we do better? This is nice, right? Can we crank it up? So we just saw that single pass usually gives us very poor results. And even adding one feedback loop is making it way better, right? What if we loop it and generalize? So basically, this is the next pattern called refinement loop. So what do you do? So this is a refactoring process by Lowell and Falco. I've been running it for a long time. I have something else now, but like this shows the idea. So first of all, you have a goal, right? This is a process of refactoring production code. So we're trying to refactor. Then you give it one step towards a goal. Hey, take one step. Hey, perform the simplest possible refactoring here. And the next thing is commit every time after it and start a new one again. And this is what makes iterative and makes a lot of difference, because if you just say, hey, do one step at a time, it will absolutely pretend to do that, and it will not, and the difference will be dramatic. The output will be much, much worse. So this makes it forces it to iterate. And then basically it surfaces problems and kind of I think why I think it works really well is I think it's with humans too. Like when I see noise in code, it's really hard to think about deep problems with it. I just need to get the noise out of my face. Then I can notice the next thing and the next thing, and I can improve it gradually. So I really like this process for a lot of things. And then there's this refinement. So the refinement loop, basically the idea is, if you generalize, you can define your goal, right? And it can be many things. So it can be refactor code, it can be improve quality, or like simplify. I really like simplify. And then get to the gist of idea. I really like this get to the gist of idea. I have this thing where I go meditate in a file instead of the git commits, and it goes, and the process is basically write a thing. I'm trying to improve it in this direction, so it has a goal. Write a file, take one step, try iteration, then write another file, improve in that direction, and only show me at the end of this, right? So AI basically takes one pass, and I recommend the simplest, and then save immediate steps somewhere to force iteration, right? And that actually produces really, really good results. One thing that I see is like you repeat this until AI sees nothing to improve, and what I see a lot here is AI has less standards than I do, and it stops too early. So what I do here is basically I have to kind of tell it to do more. Why introduce lenses? Lenses is the idea of it. I ask it to do more, and also say, hey, also look at those directions, different things, because I went through my refactoring process several steps. I experimented a lot and did a lot of like, does this work? What did I learn from this experiments? And I ran like 8 experiments with the same process. I see what's problems in there, and then I try something else and so on. I improved my refactoring process this way. And what I saw first was AI is not good at determining whether quality is good, not as good as me in that, or at least my quality needs to be better than that. And then when I force it in a Ralph loop to do improvements infinitely, then it wasn't thinking about the same thing. So I introduced lenses. All right, let's think about the size of the functions separately. Let's think about the formatting separately, and so on. So that's the idea. And then now it's ready for the human feedback. So like this is where you review. You don't review before, you review here, right? I think about this as a giant centrifuge. Imagine like a centrifuge, and you spin it in a loop, and it gets all the stupid out by using AI to get the stupid out. And now it's ready for review. So save you a lot of effort. Like, don't look at the first dirty iteration. It's never good. Yeah, that's the idea, right? So the concept of AI slop is pretty prevalent, but there's some ways to deal with it. This is mine, right? You can first ask AI to find problems with AI, and then you can also spin it in an infinite circle until you're actually happy, and that makes a lot of difference. So people are very hesitant to say that they write things with AI. I do. Well, I do typos and I do a lot of bad things, but I don't just prompt AI and say, "Hey, write stuff with me," right? it's a lot of work. It's a lot of work because I actually go iterate and distill, and like at the end, I'm actually happy, and it's much better because I used it for increasing my capacity as a human, teaching me things that I didn't know, and fixing my English at the same time. And then I edit it as well, right? So and this is how. So my refinement loop, it's in my skills, is pretty helpful, and I do it in several iterations. So spin, then show me. Okay, I'm not happy. I want to go in this direction. Spin, show me. At the end, it's really, really good. So I do this with the code, also produces really, really good results. All right, and then the next problem is selective hearing. So the problem here is this. Basically, you're very careful with your what goes into your the context, right? You have very small like main Claude MD or something like that. You narrow the scope, and still some rules are not being followed, right? Happens, and there's two types of stubbornness I found with this. First type is you're going against agent training. And if that's the case, you kind of game over for you, but also there's ways to deal with it. But like out prompting, it doesn't work. Another thing is it's getting distracted. So conversation having going on for a while, it's a lot of things are going on, and you're kind of losing control. Maybe you're hesitant to restart right now, but basically the problem is because it's getting distracted. Um, so if it's like agent training, so examples here would be like code commenting, right? So if you try to ask AI to not comment your code, you know how yeah, not very working that problem is, right? And if you look at the Claude, like a system prompt of Claude, you know what you'll find there? Don't comment my code. So it's turtles all the way down, but it doesn't work, right? Begging doesn't work because why? Because this is basically like comments are so prevalent in code. It just doesn't. It's not a reliable way to do this. So you have to use force. So here. So basically, what helps here is you just let it do it and then take it out, right? Don't stop fighting with it. Have a way to take it out, to fix it. And I saw it on the Whisper model as well, like quite a lot. So Whisper model is a voice-to-text model, so you talk to it with voice and it transcribes it, right? And I show the applications that I build with two clients. But this thing has a problem of it hallucinates stuff on silences. So it's been trained on pretty much all YouTube. And in every YouTube video, you have what? Like, oh, please like and subscribe, right? So it starts hallucinating on silences, this stuff. So the way I basically do this is I detect all the different ways it does it, and it's usually pretty like it's a subset. And I basically have an editor that fixes it instead of fighting, because I can beg model, please don't do this, please don't say applause, but it still won't be reliable. Scripts are reliable. And then with distractions, so you can do several things. You can refocus it, right? And by asking, by reminding you what's important. So basically, it's a reminder. So let's go into a little bit more detail with this. So hooks are pretty much the pattern that helps you fix it afterwards. So it's a big gun. The idea of hooks is, I think maybe they're not in every tool yet, but I think they will be. They're really powerful. The idea is this. This is your agent. Agent is basically three components, main components. There's an agent, like code that talks to agent. There's memory and there's tools. And there's some LLM. So there's one REST call to the LLM from the agent, right? That is the non-optimistic bit of this is this REST call. The rest is code. And if this is code, you can hook up into lifecycle of this and have control on when conversation happens. So when you as a developer start talking to it, you can, for example, have some events that do something. Like at the start of the conversation, do this. Or when the agent edits something, do that, right? And so on. So you can do something on stop, you can do something on before edit tool, before after edit tool, very powerful. One way, like what I do, for example, with comments is this. So this is me messing up with my agent. I'm like, hey, agent, can you add comment? And there's a hook to kind of ask it not to, right? So I ask it to do that, and then the agent goes and adds this is a hello world comment, right? Very helpful as they are. And then the tool basically at this point screams at it, right? So the tool says, hey, you're not supposed to add comments. And the agent was like, oh, sorry, human, let me take it out, right? And also that serves as a little reminder, and it will behave for the next 5 minutes a little bit. So that's nice. That's one of the ways. Like hooks are very, very powerful. You can do so many things there. And one of the things is like visibility, like just that org does basically. Like we did a very interesting, fun thing. I had my TDD process produce code, and she had her stuff, and her stuff was she has hooks to control, like she detects problems, code smells, and it screams at AI for that. My TDD process just produced good code without any additional do this and do that. Her screaming it produced pretty much the same level of code, interestingly. But like she basically controls code quality this way. So really, 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 really powerful. I think we didn't even get to the what it can do with this, and I didn't for sure. Then reminders. So basically, when agent gets restructured, what can you do is remind it, right, about the important things. So this is kind of lightweight enforcing. So, and that goes to to-do lists, right? To-do lists are really powerful. So you can put everything that needs to do in a sequence of steps and ask it to follow it. That it actually serves as a reminder, and you can bake in sneaky instructions. So this instruction sandwich, for example, here is, so this is my to-do list. I'm trying to refactor a thing in separate steps. Here's a step, right? Before that, go run tests, do stuff, then run tests again. That's kind of instruction sandwich, right? So put important bits that it, instead of saying, hey, always run tests when, you put it as a part of the things you care about, part of the steps, and then it does it, and then there's another instruction sandwich. Much more reliable instruction following this way. Right, so that's the idea. Basically, sometimes there's so tricky instructions, and like no matter what you do, you can't out prompt it. There's some power that hooks give you and reminders, basically. So that's the idea. I think I wanted to just talk briefly about the gist of non-determinism. So think about the die, right? So non-determinism is die. It's a little bit of the problem. You don't always want to have random answer to your problem, right? But also it can be helpful. And how do you control this? So first of all, several things in parallel, several die in parallel help, right? Because you can steal ideas, and you can also have one that worked really well and pick that. But another thing is you can do is a loop, right? And loop is, this is Ralph Wiggum technically, but also like used for good. So reinvest yourself until this piece is good, and then continue. Some people just go continue in Ralph loop. But you can also reinvest into your code. So think about it this way. This thing might fail. This is a non-deterministic. How do you get a outcome of practically always good, or practically always the outcome you want? If you roll a die many, many times, it will once hit it, right? So basically, that's the idea. So you get a specific outcome reliably by just repeating it and asking it for the things you care about. Yeah, and the small feedback loops with AI and picking the right tool for the job is also important for this. So that's the idea, right? So do you guys have any questions for this part? I think I'm running a bit long, but I can stop for questions, or we can do it in the end, whatever you prefer.
Length is okay, Lada. This is a lot of fabulous information.
Thank you.
So I can come up with a question. I always have them. So at a very high level of these patterns that you've submitted so far, which one would you say are like high calorie versus low calorie? And the reason why I bring this up is because there's been some, I guess, very high level feedback from some companies which were all in on like token maxing and then suddenly switching to token minimizing. Like which one of these would you not implement if you were trying to minimize your usage of tokens? And which one of these,
Oh,
you know, or I guess which kind of like it kind of might be obvious, but maybe some of these are not obvious in terms of secretly using a lot of tokens. Does that make sense?
I think noise cancellation is probably your biggest friend, but also RTK is a thing. So like, there's a way to kind of make the bash less noisy. So I would probably go to that and reducing, like for example, so I really like what Llewellyn is doing, Llewellyn Falco with test SH. So he has a test SH script, and when the tests are green, it outputs one line instead of the whole test suite. It outputs 100 out of 100 green. Cool. That's all you needed to know, really, right? So cut this noise out by having a tool set like nuke all that. And when it's failing, it actually shows you the whole thing. So that's the difference, right? But yeah, I think noise cancellation is the biggest one for tokens specifically. I don't tend to think of in tokens. I have a 200 Claude plan. I don't tend to run into limits, but I think it's just, yeah, I got lucky, I guess. But yeah,
Lada,
Uh-huh.
to piggyback on what you're saying is if you're token constrained, one of the things that even Anthropic is doing and demonstrating is see what of the things you're doing can be automated with a bash script or something in the terminal, like
Yeah.
Llewellyn, and to minimize the feedback from it. So offload it into scripts rather than AI.
Yeah, that's excellent. Thank you, Steve. I think that's very helpful, high level. Actually, that what comes to mind is Arlo as well. I talked to Arlo a lot about how he uses AI. It's fascinating what he does. He thinks about it like you control the universe of the AI, right? So what you can do, what he does a lot, he doesn't. I didn't tend to use MCPs because MCPs used to put a lot of garbage in your thing. But like if you write MCP yourself, you can write it good. So he writes his own MCP, and it gives the agent only the things that he cares about. So it doesn't give it the whole bash. He just gives it the things like the reliable script to do the committing the way he likes that kind of bakes that as one operation to pull in, right? And basically that means that instead of small little steps all the time git, it has one lever and it does the thing right. Non-deterministic, but also noise canceling. So I think from that perspective, this could be also good. Yeah, just an example. All right, shall we continue, or do you guys want to talk now? Okay, let's talk at the end. So, all right. So the last bit is about conversations with AI. So how do we talk to AI better and get better interactions? So so there's two problems around interactions that are pretty dramatic. So first one is the AI internals are hidden, right? So and the thing is, I don't like to think about AI in anthropomorphizing that. But it has something that feels very much like a mental model. So I'd rather I can just call it that, right? So it has some idea about the world, and the mismatches there with me, human, can be both very costly and very hard to detect, right? So this is what it looked like in my experience. But like before that, so there's another problem that makes it more complicated. So it also is something that has been deliberately trained to obey you, right? It has been deliberately, there's a bias put in there deliberately, because I think the first versions basically started arguing with you and so on. So they train it to be obedient, right, for you. And it will do anything you kind of ask it to, for the most part, and also silently. So basically, we are dealing with something that's a black box, and also it has a compliance bias, so it obeys you. And the end result is basically you have a black box that is very mysterious, right? So, and the manifestation of that is something I saw in this pattern, silent misalignment. So this is what it looked like. Basically, I had this first iteration of a project I was working on, and this is a kind of UI. I already did the backend. It's a way to fill in the form with the voice. The voice goes here, form is filled in here. But I mostly was working on backend, but front end was ugly, and now like I figured out the backend, and now I'm ready to kind of fix this. I don't like that this line and this line is not level. It's not meant to have this giant white space. So I'm like, hey, go fix it, please. Make there's a left panel and the right panel, and they are not on the same height. The beginnings of it. Can you make it on the same height? And so this is what I think about the top panel, and this is what I think about the bottom panel. And I went to it and asked it to do it, and it went and did it, and it said, hey, I fixed it, it's level. I go at it, look at it, and it's not level. I'm like, hey, no, it's not working. And there was several interactions back and forth with it actually said that, yeah, I totally fixed, and it wasn't. So at this point, I got this suspicion, right? So now I'm like, hey, AI, how about when I say top panel and left panel and top right panel and like top and bottom of the right panel, how about you color these different colors, all four? This is what I see, right? So thing is, in my world, uh, it's not the same, right? So what it colored was this. So at this point, it's clear that it didn't understand me the same way, right? So this is what it said, but it was completely invisible until I asked it to, and it didn't tell me anything, right? It didn't tell me like I don't understand it. So the question here is like, when I go and ask it to do a thing, why didn't it kind of not ask me hey human, you're not making any sense in my universe, because what did it see? It saw a bunch of divs, right? I was talking about left panel and right panel, and I was talking about top part of both of them and bottom parts. What it saw was divs, right? There was nothing about first section and that section, right? I didn't make any sense in its universe, but it didn't tell me that. So it's really hard to suspect, right, that it's even happening. So why wasn't it telling me that I wasn't making any sense? Because of those two biases, right? Because of those two problems. So what you do to combat it, you have to kind of ask it, you kind of have to give it like, please actually tell me stuff, right? You have to fight those biases. So the active partner pattern does that. So basically the way I do it is, I already showed you this, so tell me something I need to know, even if I don't want to hear it, is in my ground rules, but also push back when something seems wrong. Don't just agree with mistakes, right? I would rather not agree with my mistakes, not tell me that I'm so perfect. Or ask questions if something not clear, if you need to make a choice that's important. Or if there's an error I miss, also like tell me. And I really like this emoji for this, because now I see that this rule also hit. I'll show you that in a second. So, right. So basically forcing partnership. How do you do this? Global rules with like allow it to give you feedback, right? And then permission to disagree, proactively point out mistakes, be proactive. And then impromptu prompting, I also do it in impromptu. So like tell me about it. You know, so this is kind of reinforcing that ask. And then I'll often say, what do you have any questions? And again, this is what I do instead of saying, do you have 5 questions? Because I see many people asking you to give them 5 questions, and I don't understand. Because like, how do you know how many it had, right? How do you know what questions are important if you didn't see them? So like, you're sticking yourself here, I think doesn't help, because if it had more questions, what is the 6th one was the most important one that you needed to know? Or you ask it 5 questions. Do you have any doubt that it will ask you ask 5 questions, even if it didn't need to? So now you're wasting your time explaining and talking to a talking machine about things. So yeah, I find this very helpful. And then I often ask, is everything clear? And oftentimes it says no, something's not clear. Right. So the next pattern is check alignment. So the idea here is also like to help get aligned with this thing. What you do is basically this. So you have a request and you like planned a lot with the AI, but it understood you and it failed in the end, right? So there was some misunderstanding here, but it didn't get uncovered until it went and implemented. Then you see the issue. So what you can do instead here is you go to AI and say, hey, actually, so if you wasted 20 minutes, so what we say is like, hey, show me current architecture and what you plan to do. Or tell me what is the step you're gonna do? Show me what you're planning to do. And now you see it, and now basically if you catch misunderstandings early, and if it misunderstands, it implements the right thing, but maybe it doesn't work. Maybe it does, but it doesn't. If it doesn't work, it won't fail for that reason, right? For misunderstanding. So basically check with it what it's gonna do and make it show it before it goes and does into a long spiral of implementation. So I find it helps a lot. So the idea is black box AI and compliance bias is something that leads to a mysterious box that is pleasing, and like misalignments there are costly and hard to detect. So the way to combat this is actually make it active with you, right? Active partner. Make it explain that it's okay to disagree with you. Encourage that, because that will actually like make it better for you, right? And then check alignment is a way to be like, oh, before you go into a long spiral, let's align. Like, are we on the same page? Cool, let's continue, right? So that's the idea. Then context markers are basically something I showed you a little bit before. So the idea is it's my little trick, right? So I saw this when people started talking to AI and asking to call you a specific name. So like I tried it, I thought it was hilarious. The idea was like, when you see it calling you with that name, you know it read your ground rules, right? That was the idea. But with the names, it got really, really old really quickly, I found. And I really like emojis for this instead. So what I have is this. So always start replies. This is my ground rules. Always start replies with starter emoji and a space and default to this, right? And also you can stack them, so you can have several of them if you want. So now my communications with the AI look like this. I ask it a question, it's like 4, right? So, and this clover is an information. Information is, it read my ground rules. right? Very helpful. And how it manifests is because I have the starter character, I can do other things now. So what I do is I can replace it completely. So for example, for a refactoring process, I have just this one thing that replaces the clover. Or when it's in committer role, it's actually additive. So I have both the clover and this thing. So I have two emojis. So now I know read my ground rules and it's committer. And then the test green refactor, very nice because now it's scannable. Look, oh, it's in red phase. It's doing things. And now it's in grid phase. Yeah, very, very easy to see now, right? So basically what I see is basically things like this, right? So test is failing as expected. This is information. Read my ground rules and it's in red phase of TDD. Nice. So there's basically, ooh, I was trying to go into a window, but okay, I'll show you later. All right, so the next pattern, anti-pattern here is answer injection. So this is a tricky pattern, and it's really good to know. So in the simple form, like the trivial one is something like this. So you go to an AI and say, hey, I need to organize a team celebration. Which fancy restaurant should I book? It'll absolutely tell you all the fancy restaurants you should book, right? What it's not going to tell you is, oh, there's a special event right now in the bowling thing that you really like, right? It won't tell you that because you didn't ask. So what you can do instead is go broader, right? You can say, hey, give me some suggestions of what to do. And now the outputs you get are much broader. So that's the idea. So in the first one, we kind of limited the solution space to only the problems that we asked for, right? But thing is, like, this was obvious, but it's not always obvious. And the one that I was like the most, where I actually noticed this thing for the first time for reals is this. So I had two cloud codes, a left cloud code and right cloud code. And last June, I was like running into frustrated with it and also like wanted to play and I wanted to have two cloud codes talk to each other, right? And it wasn't a thing then. It wasn't possible then. So I go to cloud codes and say, hey, this is my main one. This is my reminder, right? So this guy, for example, the idea was this guy will code and this will kind of talk to it and remind him it about important things. June last year. That was a long time ago, right? So I went to it and said, hey, can you send a message to another cloud code? Do a research. And at the time, it wasn't a thing, and that was kind of supported by Cloud Code. So it went to research. I was like, no, Cloud Codes can't do that. But this is not what I meant, right? So thing is, I got disappointed that I thought it wasn't possible here, right? But what I really wanted to do is a different thing, right? So this is what I wanted to show you instead of this. Let's see if I can show you. Interesting. Yeah, there you go. So, for example, this is a left Claude code, and say I can start like Claude, right? So two Claude codes. Sure. And now can I make this one launch this Claude code, right? Because I'm trying to basically to get into a series of steps. Can I have, so I can launch it by saying Claude. Can I make my AI launch it to say Claude? Because it's a shell script, right? Why can't it do it? Can I do it on the side window? So I figured it out and asked it to do that, right? And basically now I have a tool that can do that, right? So launch Claude code, it goes and launches it and says, here's a window on the side, right? It did it for me. So, and now something else happened by mistake. I basically said launch Claude code when another Claude code was open already, right? And what I see is this. It went to this thing here and it says launched. But to me, this is a message. So imagine basically this. So like I say Claude, so this is already launched, right? And I say, hey, launch Claude. And I see this. To me, this is a message. I don't know about you guys. To me, this is sending a message. So I'm like, wait, you can actually do that. I was just not asking it right. I think this is where I thought it misunderstood me. I didn't mean, is there a supported feature in Cloud Code to send messages? I was like, is it possible to do this in any way, shape, or form, right? And I didn't understand, and I got discouraged because I thought it wasn't possible, right? So you can send messages to the other Cloud Code. I just wasn't asking right. That's the thing. So, so the thing I asked was, can you send a message to another Cloud Code, research if you need to? And there's a sneaky kind of prompt injection here, right? So it's an answer. I call it cheekily answer injection. You injected the answer before you asked, as you asked this question, by the way you asked the question. So the answer injection is like, does Cloud Code have support in it? But that's not what I meant, right? Instead, I went at it and said, hey, I have right panel and left panel. I'm trying to have one thing send a thing to another thing, so I can have something appear there. Is it possible? And then it was absolutely like, I'm describing what I'm trying to do on a higher level without telling it how to do it or the solution to that, right? So and it totally, and here I wasn't even bringing in the terminals. So here it went and like, oh yeah, sure, you can use AppleScript and iTerm and other things. And like, I didn't know AppleScript existed. So I just broadened my universe. I didn't know it. It taught me something that I didn't know existed, right? So it taught me a new thing completely. And I knew I could use Tmux. I just didn't want to at the time. But that's the idea. So basically, yeah. So now that you know that you can limit yourself by the way you ask questions, you can actually do this deliberately, right? There's blind spots. There's probably always blind spots. If it's important, you can start looking for them deliberately. So the cast wide is this pattern. Basically, we just learned that AI is extremely well read. Well, we knew that, right? And you can actually limit yourself by the way you ask questions. So can we do better? So the idea is this. Basically, this is my friend limiting himself. So here, what he did is, this is Hack for Good. We're trying to find a way to send emails to a specific person, right? And the way he asked is this: hey, here's ideas. The ideas can be around going at an API, doing the server, and third-party email client. He was thinking, I think he's doing lenses. He was thinking that he's trying to broaden the horizon. But like, do you notice the slight answer injection that's here? It was hard, right? It's also subtle. It's subtle. What's not there? All the things, right? And the way you can like, I wasn't happy because it would almost run us into a loop of like implementing things with sort of like something email horrorness, and we only had 3 days, right? So I went in and said, hey, no. So this is what it gave us, first of all, right? So the answer to this was this. First of all, API, here's the API options. Here's the server options. Here's the third-party options. Again, what's not there? Anything else, right? So I went and said, hey, can we do simpler, right? And I didn't say what other ideas. I was specifically fishing for a simple one. Is there a simple one than this one? But you can also say, what other ideas about this overall project or problem is not like we are not thinking about? Give me a completely different thing. Like, show me what is possible. And then it was like, oh, you can just do file stuff, and it was enough for us. And this would make a ton of difference on this project, because really we needed 2 features for the client that we needed to deliver in 3 days, right? And we didn't even think we would do both of them because we didn't think we had time. But going simple here meant the difference of they actually got funding for their non-profit organization, which made a ton of difference. We supported them in what they needed in the first feature, and also we were able to deliver this one, right, by going simpler. So you can fish for things you're not thinking about. You fish for blind spots, or fish for simpler solutions, and deliberately looking for that. So that's the idea of cast wide. So yeah, and it suggested me something else. So deliberately look for your blind spots. What haven't you even considered? What can you do it simpler than that? I really like for pushing for simple. And what entirely different thing can work, right? Really powerful. And yeah, teach it what you don't know, This is kind of using it as a vision, like a vision tool for yourself. Another pattern that's similar to this actually a little bit, and I really like this one, is reverse direction. And we're getting close to the end of the thing, but yeah. So the idea is this: conversations often with AI, often I see people doing this. So, hey AI, do this thing. Okay, do this thing over there, that thing, also this thing. So you notice how it's one directional, right? Conversation have something like inertia, or people tend to talk to AIs in a way that kind of is inertia. And often also what it feels like as well is like what it manifests is as this. AI asks you a question and you go and answer without thinking. Because you're in a conversation, we have conversation protocols with humans, and we kind of start applying this to AIs. Like, but you are not talking to a human, you're talking to AI. And they're not thinking that they don't have to answer because of this inertia to answer this question. They actually have control. So what you do instead is you take control and think where you want to go instead of answering. So what you do is this: hey AI, do this thing. What would you like to do? What's the question? Well, I can answer that question, or I can ask you, well, suggest me something. Do something like what are the options, right? And also fishing for additional things that I'm not knowing, like I don't aware of, and it returns so much more control. Like you don't have to be treating it the same way. Like take control where you want to go. You actually have a choice. So what it looks like, for example, in this simple example, I had this script I didn't like the name of. Can we rename it? This is my prompt. I ask it to rename it. It's like, what to rename it to? And many people think here, and this is interesting because I think it's not helpful to think here. You can think about it here, but I often do, hey, can you suggest me some options? And that does several things. So so on Craft, I found I had a really good there was a really good talk by Goiko. And what he said is basically this: it's easier to complain than to explain. So when you see ideas, you get more ideas. So basically, this is what it gave me, right? And this is like, ooh, I do like this one. I actually thought about Whisper and other things, but now I see things at a glance. It gives me more ideas. So now it's easier for me to make it, right? Easier to complain than to explain, right? It's easy. It's harder for me to come up with a good idea, but if I see stuff, it gives me more ideas to do things, right? So that's the thought here. So when I see more options, I see more ideas. And I also quickly see what I like and I don't like, and it's easier for me. So that's why I think it's really powerful and really helpful. And also, like, you have control over where the direction goes with AI. You don't have to just follow what it prompts you to. It's like it's prompting you and you're following the prompt. Well, you have choices, right? So yeah. So I often had this conversation with AI in the last year, and I kind of hate this conversation. And I want to show you the trick by Arlo Belshi. It's basically a combination of like several patterns. There's like a chord that's really powerful that I find very helpful. So uh, I had a conversation like me asking like what tech stack are we going to do this in? I check alignment, right? And then AI is like, well, we can do this, this, and that. Which one do you prefer? And here I'm like, which one is better? So this is reverse direction, right? Which one is better is why? Show me. And it suggests something and so on. And then I'm go ahead, right? Uh, so many types of things I do this in, like not just this, it's just an example, but so many conversations went like this. So what Arlo showed me is basically this, and I really like it. So when you need my input on the decision, this is my ground rules. First, pick an option that you think is best and propose it. So UI, you have an idea already, show it to me immediately. Start your message with a star. Now I can see that this is the one you prefer. Also list the ones you didn't see. Yeah, this is cast wide. What are the things we didn't choose? And shortly show it to me, right? And then we can have a discussion. So I really like this because this is all of those moves in one, right? And what I see is basically this: hey, what are the things we can do? Here's the paths before us. Here's the idea that I like. This is why, and also this is why I don't think it's a good idea. Oftentimes I see something that is a good idea and I have a purpose for it, but I ask it to show it. Now I can see it and I can choose this. Saves a lot of effort. So this is kind of a chord of patterns that I really like from Arlo. Yeah, so this is what it look like. So this is my prompt basically that goes into the Claude MD. So this is what I'm asking to do. And basically the cell patterns, reverse direction, check alignment, and cast wide all at once, right? And also context markers I showed you. All right, so almost at the end, and I know that I ran long here today. The idea of context markers, basically we're dealing with invisible thing, and this is one of the tricks you can use to make it visible, and you can put it in digital instructions and other things. Yeah, I like it. Answer injection basically is a way to shoot yourself in the leg. Happens with humans, especially bad with the eyes. It's really hard to notice when you basically putting assumptions about what solution would be into your question and then limit yourself. But you can also start looking for blind spots. And the reverse direction, basically, hey, you have control in conversations. Lead it to where you want to go, not let it prompt you, right? And then the text native is the last bit. It's kind of a small thing of a combination of several things. But what I want to show here is so text native. Basically, we again hack for good, and we're trying to modify an application. So we have on the left side we have a window, and I'm trying to go to the right side. So we had this window, we're trying to modify this to a right window. How do you explain this to AI? So most people will like start typing something, or I do a lot of voice conversations, so I'll just start talking to it and explain yourself. You have choices here. So AI is really good with both text, but also pictures, and you can move between them. So here, let me show you how I move between that. So you can basically, my designer, like my team, draw this together on the piece of paper, right? And I have this. I can go and retype it, but I don't have to. I can just say, hey, here's a picture. And I wanted it to be less noisy, because to me this is annoying. Somebody is writing that. So I'm like, hey, convert this image to ASCII, right? And this is what it does. So really nice. Kill me now. I will not type this thing out, right? I will not type this. But AI can, and it costs 0, and it's very easy. Now I can also edit this and I give it back. So now it becomes a whiteboard. And you see how good it is. Like model, both windows, continue button. There's a copy there, and both things, and perfect, right? So it really understood me. Nice. And then what I do here, I have a picture now in a way that is very readable for me. And what I do next is a move to go to convert this picture into text. So I want to explain. My goal is to explain the new state to the AI. I want this window. Hey, explain it yourself. You look at this, right? Explain it to yourself, like write me a window description. Here's a window description. There's a model pop-up with 2 sections, summary section, and button, right? Perfect. But I didn't have to type it. Nice, right? But now we have the future state. So I went from a drawing to a future state with very, 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 very lazy process, right? So you kind of can move through this through 2 modalities here. Now you're trying to explain the future state, right? So now you need to know. So we have it in desired state. What's the current state? It has it in the code, but it would be really nice to have a to-do list. To have a to-do list, it would be really nice to do this. Basically, I have code, right? And I can go and tell it, hey, look at the code and make me a description of current state. This is the equivalent. So desired state, we're going to a current state. Now we have the current state. We have this. We would like to go there, please. And you're looking at the code, and you can basically construct that whole thing from the code, the current state. And now you're like, hey, make a to-do list to move between the two, right? Now I have a process, move between the two. And here's your to-do. Guess what my next prompt is? 1 sentence, go implement, right? Point to the file. There you go. And like, notice how little effort I wasted here. Very little effort, right? So you can move and use modalities. I moved through different modalities. So I went from a current state to a picture of a current state, converted it to text, and then went to diffs of two states, had them all explain. I had it explain to itself what it needs to do by showing it before and after, right? In the end. And now it went and did it, and it was perfect from the first try. And I also knew that it will do the right thing because I saw this stuff in between, right? And it was pretty good. Yeah, so that's pretty powerful. So that's the text native. Basically, it's text native, like it's really, really powerful in text, but also have other modalities, and moving between them is pretty good. It's like the second modality, it's also pretty fluid pictures. All right, so in the whole thing here, I really like to think about what limitations we have, what we're dealing with, and I find some people reported that this is more important than the actual patterns, because patterns you can maybe come up with your own and so on. Like there's a lot of like things for this is solutions, right? But the problems are kind of, and they have been pretty stable in my experience. And just to sum up to go to the whole thing, and then we end. I know I ran along a bit. So all right, so AI can't learn, right? So the choices you have is you can reset or refill, and you basically have to manage context. You can't just shove things indefinitely. You are building its knowledge basically externally through memory and memory through tools, right? So you're building this memory and library for yourself. AI has attention also, right? That's another problem, and it's scarce. So you have to kind of manage it. But so that's why little agents are so powerful, focused agents are so powerful. You can focus and get much better results with this attention. And then text has become elastic. You have control with text, and you can ask for immediate meaning instead of all the noise it gives you. So use that to stay sane in your code bases and in your documents. It's really powerful. And then yeah, it's not deterministic. Same input, it's not the same output. A problem and not, because first of all, if it's a problem, if it needs to be safe, right? Design for it, right? You know that this is a problem, so put a mat there so you don't fall. So protect yourself. How do you protect? Null checkpoints is one of the ways. Save it before it goes and does stuff. right? Parallel implementations, you can roll dice several times. So this is exploitation of non-determinism, right? Or you can like spin the same thing, right click them, and get to the same outcome, to the good outcome by just trying it many times. And then a flow deterministic basically is about picking the right tool for the job. Don't just use AI as a hammer. Use the thing that actually reliable and give AI tools instead of asking you using AI for everything. And then you have to manage complexity because AI doesn't do it by default. So I showed you some simple ways to do that, like right chain of the small steps is doing that. And then basically like with AI slope, just expect bad quality. It won't be good. So refine for it, right? I show you some of my tricks. I bet there's much more. Super curious about yours. And then so you refine for quality. And then there's tricky instructions. There's some ways to deal with them. I showed you some of mine. And then with conversations with AI, so the problem is that the AI mental model is hidden and it's trained to say yes. So we have this mysterious boxes just trained to agree with you, and you don't know what's happening there. So misalignments are super costly there. So what you did need to do is you have to actively fight that. Right. Don't and another thing with that, so checking alignment, but then again, you can potentially accidentally limit yourself by the way you talk to it, and it's really good to know, right? And then expect it, and then you can maybe start fishing for the blind spots. And this is becoming an instrument of vision instead of just, like the tool of like taking commands, which makes you much more powerful. You have the knowledge of like the whole humanity at your disposal, and if you just ask right, it will give it to you. That's so powerful. And then, so AI has crazy breath, use it. And then text is really powerful, but also like move between modalities. You can save yourself a lot of effort, super powerful, so many things you can do with this. So yeah, that's the talk. Thank you very much for your patience. I know I ran long. There's resources. So thank you. But like, let me just briefly go through resources, right? So this, what you have here is slides. There's a companion website. If you go here, basically we have this website and this whole thing you can click. This is the last version, so it goes defaults to there, right? So use that to kind of, if you need a reminder. And then there's patterns repository. Basically, this thing lives in the repository, and you can submit pull requests here if you'd like. We not promise to accept everything, but we will definitely be grateful and look at it and consider it. And then, yeah, so I have the skill factory basically with my skills that are pretty helpful to me. I use them a lot. There's a way to enable them like this. So go here. So all my skills are basically, this is a symlink to a specific folder, so I can enable, disable it at any point, and I go to skills. Basically, you see this is symlink, so I turn it off and it's unsymlinked. So I give it to you if you want to explore it. The things I went into is like, for example, refinement loop is this go meditate into a file, really helpful. So if you want to like to explore the things, they're at your disposal. And yeah, thank you very much for your time.
Awesome. Thank you so much, Lada. We're not done yet, but I wanted to inject. I know it went a little bit long. Some people said this was definitely worth it, even with the length, and I agree. I think that there's a lot of payoff to listening and staying engaged and working along with it. We'll have Q&A here in just a second. I wanted to let folks know that Yvette.org is coming next month to start talking about stop reviewing AI slop. It should be a fabulous talk. Yvette is also a friend of Lada and a few people here. So yeah, she's got some good thoughts and ideas on that. And yeah, I thank you. I'm going to stop recording and open it up for Q&A.